Hi everyone. In this video we're going to be taking a look at solving proofs using the two new rules that we learned in the last video. One thing I want to mention about these exercises is they're a lot harder than the previous exercises have been. I didn't do this on purpose. It just happened that all the exercises that I was making started becoming really hard. What I think happened is that I was getting really excited with all the rules that I had at my disposal. So right now we have 16 out of a total of 18 rules, so we've nearly covered all of them. And because of that, I have a lot of flexibility in the rules that I'm able to use. But realizing that I was making really hard problems, I tried patting it down with some easier problems. So I hope I was successful in doing that. So in this video, in these exercises, some of these problems are just tricky, and others are tricky and really hard. So we're going to be taking a look at a bit of the trickier ones because I think this set in particular should it sort of warrants it. So let's get started. We'll be starting with an easier one. So this is a one premise argument, or it has one initial premise. So the only thing I can see that I can do here is distributive. So I'm going to start with that, and we'll see where we can go from there. So I'm going to get P and Q or R through one distributive. Now from here, I can either simplify P or I can simplify Q or R. Well, I can see that the conclusion has not not Q and R then P. So I'm gonna need one of these two by itself. So it might seem like if I got Q and R by itself, I might be able to do De Morgan's and get not Q and R. But if I did that, if I had Q or R, and then let's say I did double negation Q or R, and then from there I did not Q and not R through De Morgan's, this would be a different conclusion than what I have up here. So if I got this through, I don't know, I'm just going to use two steps here, through let's say two commutative simplification. If I did it through there, and then I did 3 double negation, and then for De Morgan's, I still wouldn't be able to get what I'm trying to get. For future reference, don't use two different rules on the same line. I just did that to be really quick, but yeah, in any serious proof, I'd never do that. So stick to using one rule per line. So since I can't use Q or R, I'm going to use P. And I'm going to use P through 2 simplification. Now that I have P, I can add something onto it. So I get P or Q, Q and R through 3 addition. So from premise 4, I realized when I was trying to do these videos of 2 equally good ways of solving this problem. And what I mean by equally good ways is that each way of solving this problem has the same number of premises. So they both end in 7 premises. So I'm going to start by showing the way I initially solve it, and then I'm going to show you the second way that I realized when I was trying to make one of these videos. So let's start with the regular way. So the regular way is after premise 4, I did not P or Q and R through 4 double negation, and from here I did not P then Q and R through 6 implication, and from here I did not Q and R then P through this shouldn't be 6, this should be 5, through 5 implication. Then I did not Q and R then P through 6 transposition. So this is one way of solving this problem. And the initial reason I did it this way is because it uses both of the two new rules, transposition and the distributive rule. But there's a second way to solve this problem, which doesn't require you to use a transposition rule at all. So let's take a look at that now. So the second way of solving this problem is instead of double negating P, you can double negate not Q and R. But to do that, we need to commute it first. So we need to get Q and R or P. We get this through for commutative. And then now that we have this, we can get not Q and R or P. And we get this through 5 double negation. Now that we have this, we can get not Q and R, then P. And we get this through 6 implication. So you see, each problem has a way of solving this so that like in the same number of premises, so they're equally good. I prefer the first way because it makes you use transposition, but I mean they're both correct ways of getting the same conclusion. So they're both right in my eyes. So now we've taken a look at this problem. Let's take a look at a harder one. There's two really hard problems in this problem sheet. And they're both in the last two problems, problems 5 and 6. I think problem 6 is just a little bit harder because it has more premises. So I'm hoping that'll make problem 5 easier. But also sometimes what has less premises is harder because you have less to work with and you have to think really critically and hard. But I'm hoping that this is a harder problem. So let's take a look at it. In premise 1, I see a disjunction here. Let's see, I might be able to do various things with it. Premise 2, I see another disjunction. I see a conjunction. So I might be able to simplify this. The first conjunct looks like one of the disjuncts in premise 1. So that looks like a disjunctive syllogism. Let's see what else. Let's see. And I also have an H in my premise 2. I see sort of modus ponens in premise 5 that uses an H, so I might be able to use the H there later. I see two conditionals right here that are conjuncted, so that implies a constructive dilemma. I see a modus ponens right here, which will give me an L that I can use to get this L and H with this H. And then from there I get Q or D and P and M, then M. Yeah, so this looks kind of complicated. Let's see where we can get started. So the first thing I noted that seemed really, really clear was the disjunctive syllogism in premises 1 and 2. So I'm going to start using premise 2. I'm just going to copy and paste this. Let's see. Yeah, I'm just going to copy this as my premise 6. And I'm going to get this using 2 simplification. Now that I have this, I'm going to get just going to copy this as well. Now that I have this, I'm going to get P or Q and Q or S. And I'm going to get this through 1, 6 disjunctive syllogism. So now that I have this, let's see what I can work with. So I have these two disjunctions. Let's see where I see them. So I have P or Q and Q or S. Let's see if I could use either of them anywhere. Well, I see P or Q in my premise 4, but it's conjuncted with an E or G. So do I see an E or G anywhere? Well, in premise 3, I see a not E, and I see a G also. So that implies that to get that, I'm going to need to I'm going to get E or G in some way through premise 3. So let's take a look at premise 3. Is there any way that I can get E or G through premise 3? Well, I have Q or S, and if the Q was on the left side, I could do a constructive dilemma. So that gives me an idea of what I need to do. So with my premise 3, I'm going to get Q, then E, and S, then G. And I get this through 8 transposition. And now that I have this, I just need to get Q or S. So Q or S is my right conjunct in premise 7. So I need to do commutative Q or S and P or Q. And I get this through 7 commutative. I misjustified this. This is an 8 transposition. This is, let's see, what, 4 transposition? No, this is 3 transposition. Okay. So I did this, and so yeah, so now I commuted Q or S, and then in premise 10 I can get Q or S through 9 simplification. Now that I have Q or S, I can get E or G through 8 10 constructive dilemma. So so what I did here was I transposed this E or not Q to get Q then E in premise 8, and then I used my Q or S in premise 7. I commuted it and I simplified it, and then I just did a constructive dilemma. Q then E and S then G, Q or S, E or G. So that's how I got E or G. See, now that I have E or G, I can get my premise 4. So I have E or G, and I just need to get P or Q. So that's just 7 simplification. And now that I have this, I can get P or Q and E or G through 11, 12 conjunction. And just a reminder, once again, when you conjunct, you can conjunct in any order. So instead of having to say E or G and P or Q, you don't have to, and then commuting, you don't have to do that. You can conjunct in any order. So now we have this. We can get, and even conjuncting in any order, I still made the mistake of putting the E or G on the wrong side. So it's actually supposed to be E or G and P or Q. Yeah, E or G and P or Q. So my mistake. Yeah, so is E or G and P or Q through 11, 12 conjunction. And from here we can get L through 4, 13 modus ponens. And now that we have L, we need to get L and H. So H is in our premise 2, so we get H and then this long string of things, which I'm just going to copy and paste. Not P or Q and R or S. And we get that through 2 commutative. And from there we can get H through 15 simplification. Again, starting from premise 13, we were able to get E or G and P or Q through conjunction on 11 and 12. From there, we were able to use this to get our modus ponens, and to do our modus ponens with premise 4 and get L right here. Then after we got L, we want to get this conjunction right here, L and H. So to do that, we need to get H, which is in premise 2. So we commute to premise 2 to get H and not P or Q and R or S, and then we simplify to get H, and from there we get L and H through 14 16 conjunction. And after we get L and H, we can get Q, then D, and uh, P and S, then M. So we get this, and we get this through through 517 modus ponens. And now that we have this, let's see, what do we do? Well, we haven't taken a look at this, but if you notice in our premise 7, what we have set up is a sort of nestled disjunctive syllogism. We have P or Q and Q or S. But if we got Q or P and Q or S, what we have set up here is a disjunctive syllogism. So we get that through 7 commutative, and from there we can get Q and P and S. We can get that through 19 distributive. And so this now is set up as a disjunctive syllogism, right? And this is a really odd, not a disjunctive syllogism, a constructive dilemma. This is a really odd constructive dilemma. But, I mean, it's set up so that it works. If Q, then D, and if P and S, then M. Q or P and S, therefore D or M. And there's a typo in the conclusion where I typed in F. I actually meant D. And so that's the conclusion of the argument. It was, so it's 21 premises in total. And I'm seeing that I didn't include the other premises. I forgot to scroll the camera down. Sorry about that. This problem has a lot of different varying parts to it. But it's solved. It's not really difficult, but it is tricky, I feel. But I think it's really creative, especially in the end where I used distributive to set up a disjunctive syllogism. So I really like that. But yeah, that's the problem. Once again, I'm sorry that these exercises are so difficult and tricky, but with any luck, it'll make you stronger in propositional logic. So that's it for this video, and we'll be finishing up the last rules of natural deduction in the next 2 videos. See you then.